It's another brief moment in time. We get to see the change on the timelines. We're shifting, twisting bits of technology, something lifting up the little bits of reality. While the dream drifts through the space-time, we're surely a randomly sparking the photons around me. Let the light flow from the heat show when the photons ignite, highlight in yo. Then you'll know it's the time when we force a change in our mind's eye. Ho ho! A little bit lit us with something in us. It's almost like we something else, autonomous, or maybe perhaps it's that missing piece you need. Perhaps it's that simple message you're searching. Perhaps it's just a different time framing. Us giving back the fake you in the mainframe. Getting excited, so are the photons. Don't lemonade sweet can change the coupon. Let me raise the heart, make the cubes, that's the right one. Major bags. Ramps of technology, my cryptocurrency and hashing. What's the QR? It doesn't matter, 'cause this was 3D change perspective. Welcome to the show. Welcome to the show.
That's right, everybody. Welcome to the show. It is me. I'm 3D, and I bet you're here to learn something about something. So let's go ahead and get into it. Basically, like you see it, we're wondering. So, have you ever heard of the Flipple Zero device? It's a little handheld, whatchamacallit, doohickey willy mobber that lets you whippy whack hit bits and like a hacky sack. So the Flipper Zero is a small form factor like machine that can do quite a bit of digital wizardry. Now 1 second while I move my cup out of the way of the screen. Sorry. But you, okay, it's a bit of digital wizardry, but you know what you can't do? Just use it. You know. And this is actually a problem with many specialty devices that are set up like this. They come out mostly for people who want to play with them. But an average Joe or a little scrappy bits jockey gets their hands on one, and what happens? The device sits around, and that's about it. Why? Well, this is what we don't really want to know, but this is what we're talking about. It's not the device is like old world devices or anything. It just those just used to work, right? So nowadays devices tend to be needing more out of the box. The Flipper device is capable of much, but requires an application to pretty much use those things. So if there's anything you'd like to be able to do, well, what up, ACU? If there's one of those that you want to do, so I'm just looking for my spot. You need an app to make sure it gets done. And if no one has made an app for what you want to get done, well then you're pretty much stuck with nothing. You have no way to get it done. So what do a lot of people do? Well, you run AI. So what AIs require a ton of electricity, work, huge infrastructures, and surely there's no way for like an AI to fit and run within 256 kilobytes. Surely you couldn't get all of that within a Bitcoin's itty bitty little bitty 1 megabyte block. Could you? I mean, that is what we're here to find out, and I'm going to use a personal journey of finding a way to maximize what my Flipper Zero could do, and actually summon upon some fairly unique AIs that are shockingly small. And how small really is the question of today. So, save for today's episode, and let me change your perspective on how big or how small an AI can actually be. So I do want to thank today's sponsors and today's partnerships. So I want to thank The Organized for teaming up with Bitcoin Live Digital Broadcasting, DB, because Bitcoin Live DB and The Organized is a powerhouse combo. I see new heights for both organizations. Now, if you haven't checked out any of The Organized early morning broadcasts on Stacks, and well, check them out. They do all sorts of different topics, and they've been growing with every day. So find them on X, Twitter, among other social platforms, or where you're watching this right now. So before we go any further, I got to thank the sponsor. We got to thank the sponsor. So I do want to thank Shieldfolio for sponsoring today's episode from within a quantum bit, as well as the Bitcoin Live TV network. Now, if you haven't seen a Shieldfolio, well, they are little black books that are made from stone paper, so they're fade resistant, tear resistant, and even water resistant. So you know the info and secrets you store in your Shieldfolio will last and survive whatever you throw at it. I personally have a Shieldfolio, and I use it for my website info, contacts, crypto keys, among other things. So these are like little black books that are pocket-sized and ready to be by your side, regardless of your adventure in real life or online. And I do actually personally own one of these. You actually use it. Me and my wife even use it to like put in the stuff that we have to use for our bills and who those are, who those companies are and stuff. So we know that little bits of information are going to be kept as long as we need it. Now on the screen right now, you're going to go ahead and see one of these sides. Let me see where it's at. I think it's over here. There is a QR. If you scan that QR, it will take you to the Shieldfolio website. Yes, you can get Shieldfolios all over the place like Walmart and whatnot. But if you go to the website and you use the code BitcoinLive20, you'll get 20% off your purchase today through their website. So go ahead and check them out after today's episode and see what they can have for you. Now, throughout the whole episode, so after this moment in time, you can always come back. You can see right there on the screen, there is a tiny little QR with a lady going, "What?" That is the Shieldfolio website QR, so you can access it throughout the entirety of today's episode. So I want to thank you again, Shieldfolio. And now, let's roll in with the roll-ins before we roll in. Well, that is what's up. And now that we're actually into what we're talking about, I want to go ahead and thank already. We got someone on the chat, ACU5. Thank you for jumping in and saying hello, Mr. Bro. Because we know who you are, bro. Everybody knows bro. ACU5. All right, so boom, boom, boom. Hold on a second while I get a couple things situated, and then we move on to the actual topic. Because, well, we are what we'd call inside the photon of the greater fourth dimension quantum machine. And I do mean it like this, as in it is allowing us to do more, and that is what we're about to do. We're about to do a little bit more on top of that. So throughout today's episode, as we go throughout, you're going to see a little thing. So here we are, we're on a screen right now. So let me go ahead and so throughout today's episode, you're going to see one of these little pop-ins. Love you too, bro. So thank you so much for showing up. And if you have any questions, go ahead and drop them in as we're talking. So you're going to see a QR pop up on your screen every time we go to a website or anything like that. That's going to be your way to find this location. You're going to be able to go to it, use it, scanning that QR. It's also in the description below if you're on YouTube. So you'll be able to do that. Even if you're watching this on the replay, you'll always be able to catch us and follow along forever. I do normally show a different one at the start, and for some reason it wasn't here at the beginning. I must have missed it. But we're just going to keep going. Today's free pre-search search query, which is related to today's topic, world's smallest AI. Now, I didn't use any of the links from this query, although it is possible some of the ones from what we have today do appear here, because we are talking about, yes, world's smallest AIs, because we want AIs to fit in a Bitcoin block. That is the whole goal. That is what we're doing. All right, so well, I got to catch you guys up before we go any further. So if you heard a portion of it, I wanted to get more out of my Flipper Zero, so I looked up to put up an AI inside my Flipper Zero. Basically, I was trying to figure that out. So a Flipper Zero only has about 256 kilobytes of RAM max. And it sounds like actually that full amount. It's actually less than that. So, because they're running other things like the operating system and stuff like that. So at any one time, so I honestly thought, yeah, we could put something at least in 248 kilobytes, like a reflective AI or something like that. Not a full-on chatbot or anything like that, but some form of AI. So then when I looked into it, it turns out that, you know, you actually may be able to ask Grok about it, about actually getting a fully AI controlled flipper device. And after talking and, well, discovering that it existed, and then going to Grok, and then Grok being like, yeah, actually there's multiple people doing this, it really got me thinking. Alright, so now let's really go on this journey. So throughout today's journey, we're going to talk about three major parts. There's going to be the AIs, no way they're that small, AI in Bitcoin, how did that happen, and then looking at the actual world's smallest AIs I could find before I present to you guys an AI me and Grok made on my Flipper Zero. It is actually a full playable video game. I'm not even joking. It's an actual game on my Flipper, 100% ran by an AI. It is insane. Alright, so boom, boom, boom. Alright. Alright, yeah, okay. Boom. We're back in. We're back in. We're back in. Alright, so basically we are going to jump in. We normally do some kind of history or something, but we're just going to jump in. We have talked about AI before in the past. You can always go to the playlist on YouTube for the show, or wherever you're watching. I'm sure you can just search hashtag 3D Changes Perspectives and something will show up. And but right now we're talking, this is kind of like the big thing that got a lot of people a little, well, at least I don't know, got people curious. It basically shows that there's other people out there wanting to basically do the same thing. They're wanting AI to expand the functionality of their Flipper. So has anyone tried using LLMs to code to make apps for the Flipper? So this is basically like asking like Grok or someone like that to make stuff. And in here we get to a point where, yeah, people have, and sure enough, some guy has actually done this exact thing. Now, maybe I might have, it might be a little bit confusing. Did someone use LLMs? Did someone code with LLMs to use LLMs to get on the Flipper, write apps on the Flipper? And it gets confusing because there are applications you can get on the Flipper that produce applications for the Flipper. Yes. But someone took it way further, because people were thinking that someone asked, did someone get LLMs on the Flipper? Why are my pages not loaded? You know, I was tracking down like an audio issue for the first 20 minutes of getting set up, and I guess I completely forgot to make sure all my tabs were fully loaded. So we're gonna have to just wait a second for stuff to load in, and that's fine. That's fine.
I'm not punishing you, I'm punishing myself. I can't goon if I'm sucking.
I can't disagree with Hypno on that one. But let's attempt to speed things up a little bit here.
Their mothership conceals itself above our very heads! Ready yourself, for they are coming!
That started to work. So as you see, Derek Jamison just pretty much talks about the Flipper. This is his main YouTube. As you can see, he goes from noob, geek, all the way down to straight up coding and more. Here's Zero with Windows development. I mean, everything. It's just absolutely insane what this man has been doing with the Flipper Zero all this time. I don't have a whole lot of ways to get a hold of me right now, man. I am a lot of it busy. So from there we found the AI that was in question, getting AI literally on the Flipper Zero. So this guy managed to get Gemini to run on it. So when looking into this he didn't actually put Gemini on it. And when I looked into it really closely, like actually looked into this guy, his content, blah blah blah, it turns out like the stuff he's doing is like he used someone else's code to get Gemini on the Flipper Zero as like a stepping stool to get internet on the Flipper Zero. And that right there is a huge thing. That means that literally allows you to do whatever you want. And as we go through, you're going to find out that getting an AI on a Flipper Zero that has internet basically is an unlimited machine tool of your disposal. You could get it to do whatever you want. That it's capable of, and it's capable of quite a bit. So there's a lot of possibility there, including like microprocessing entire websites through it, where like you could have a chat system locally running that everybody runs through some server that are through that they're outputting to the Flipper Zeros only specifically. You could even prevent non-Flipper Zeros from viewing it because it'd be a locally ran internet type thing, an intranet. So make sure you guys have this one more time before we move on, because I looked in and I found out about the AI that's on this Flipper Zero. I actually found out about it or whatever, and it's just a Gemini API made by this Darkside, and Darkside actually has a lot of good content, including like custom firmware for the Flipper, all sorts of fun stuff. And that's kind of when like this is an 8-month-old repo, so this is actually really fresh. Let me see Derek Jamison right there. Actually, I'm gonna go follow him on here. I didn't even see him on there earlier. So it's not that old, and again, we look into it. It's mostly just an API, so it's not actually AI on it. But at the same time, what all can this do? And you see right here, everything up there is all about Flipper Zero. So very on par. I'll give you that right now. Why not? So I went and found people actually doing what I'm talking about, putting AI actually on the Flipper Zero, not just an API, not using a developer hat to get it on there, but like physically on there. And this person right here, Zap, is in the process of getting TensorFlow Lite from microcontrollers running on Flipper Zero. So that's TFL Micro, in case anybody is wondering. And we're going to be talking about TFL quite a bit here because that's insanely cool, right? So a lot of people don't understand that trying to get TensorFlow on a Flipper Zero is essentially probably the smarter move right there. And guess what? There's actually people working on that. Tons. So they were trying to get TensorFlow working on the Flipper Zero. So a Tensor Flipper Zero Flow. But they're not just stopping there. It's the fact they want to get it on those types of chips. And to be honest, we're going to get further on why that is. So when we come into this article right here, actually it's not an article, it's actual paper, full-on paper. Give me 1 second. I'm going to go through and see if I can get these dang things to preload real fast while this paper actually spends its time, precious time, to load it. I can't just load it. I think that is someone telling me to hurry the fuck up. Alright. Alright. Sorry about that. I thought I had the wrong one up. I had the right one up. Okay. Woo. So, because really it was made to do generically specific tasks. And I do believe it was originally for like microcontrollers of mass amounts for automated machinery that need to be synced, so handling processes of mass types that need to be done with some form of sync. This is pretty much what TensorFlow is. Now there's another task part there it does, which is flesh detection. That's a big thing in TensorFlow. You'll see why. I mean, especially if it's handling big machineries, you're going to want to have safety features. So that's a simple type of AI, basically. These ones where they put them on a simple chip, they're designed specifically for that chip, and they do a specific task. So to be honest, that's the reason why looking into getting these AIs on these little things should be no problem, right? And I will attempt to get you to need to like build an AI agent. Sorry. Let's be honest. Most of what we're looking for, though, isn't just getting a simple AI on a small chip. We want to build a full AI agent, full AI agent-based micro AI, where AI task agents are used like plugins for micro AI that will hopefully use JavaScript for neural networks and deep memory that would be a daunting task to do, like through C or Python or Rust. So that's a bit of a goal there if we can, because that's limitations and specifications to Flipper's device. It does have the ability to run JavaScript in a unique way. It does have the ability to do plugins in a unique way, but a lot of little small devices similar to it also have that exact same setup. Easy in a unique way. Alright, now we're going to go on to the next. Let me make sure you guys have the link to this one, because this is a full-on paper. This is not just an article. Like, these people go into the thick of it, and I could sit here for like an hour talking about this paper. It's so good too. It's actually really, really good. And you see what it says: and advances in small footprint keyword spotting, comprehensive review, and efficient models and algorithms. We're actually going to get into keyword spotting later. It's really important for some reason. Okay, so here's the other paper right there. Micronets, neural network architecture for deploying tiny ML applications on commodity microcontrollers. So one of the reasons why I kind of knew for some reason like reactive AI could be made small is because there's a huge machine in factories, warehouses, and all over the back rooms of the real world that have relatively small full strut microcontroller pre-built with reactive AI to help auto stop the machines during accidents, check pressure load, measurement systems live while working to sense human or non-mechanical influence, as it's also known. Yes, to just sense bodies or flesh, or humans in some cases. So I knew that's there, but really somewhere in about 2018 is when I think I saw for the first time like major secret, like old reactive AIs going public, meaning it was finally released or discovered on how to run them on commodity hardware or chips. And it wasn't directly specifically made for it. So keep that in mind, like those types of AIs are directly made for specific chips. People are figuring out how to get those off those really specific chips onto commodity hardware, chips that are designed or pre-programmable, or reprogrammable. So because that's the reality that many of the AIs really want to work with on a very limited number of chips, because these AIs are made to do specific tests. And sometimes the tests don't really matter what the machine actually is or what it does. It's as long as the sensors are the same and the data pipelines are the same where the chip installation actually happens at. And now if you look, this actual paper is only about 4 years new, and that's not a whole lot of whatchamacallits. And when you go into it, you can see like some of the stuff on here, like cloud ML, mobile ML, tiny ML. And we actually have 3 different tiny MLs that work specifically on architecture. And now, in case you guys are not aware, NVIDIA Volta is, I believe, like integrated GPU, or it's like a server integrated GPU, and then that mobile CPU is literally a type of cell phone. And we can see like huge differences in everything, cost and load. We can see they're even considering like what's actually going to happen on the chip, what's actually going to happen not on the chip, what's going to happen through the cloud. All these little things are really considered in what they're doing, because look at this, the E-flash is a single megabyte. That is a Bitcoin block. That is a Bitcoin block. So the fact that even these systems and micronets are designed around that small architecture, it only really boosts the ideal that, yeah, this is gonna be in some form possible, but really how low can we go is the question, right? Now that we're starting to prove to you guys, yeah, we can do this, we really have something to work with, and Tiny ML is gonna be one of the ways there. So let me get rid of some of these old pages real quick while we are going. All right. This is the paper that really got me super confused. So sometimes when I'm doing these things, there are some papers that are like new to me or whatever, but the knowledge of the information isn't. And so I like to like not read it ahead of time, and I'll have a note in here be like, read the first paragraph or something like that. And this is one where I was actually reading, or I was trying not to read it, but I was looking to see what it was, and I got through this entire header before it hit me that it's in, it's in French. Like, I didn't even see this part, right? I got down, and I was like, okay, I didn't even notice. I come to the abstract, not thinking twice about it, and then I come down and I see the resume, and I'm like, isn't that like the same damn thing? And then the very first word caught my attention, and I was like, oh, that's... So, constrained deep learning for MEMS sensor-based applications. So, this is only 2 years old, and is about putting deep learning on MEMS sensor-based applications. To be honest, this is an insane paper of generic pre-builds allows for custom learning suit to the device. This actually may have you wondering, what is MEMS? Well, I'm glad I asked. So, and even says, let's talk. Yeah, let's talk. A comprehensive guide to MEMS sensors. So, it says it somewhere here. It's my notes. So, tiny little measurement devices, MEMS specifically means micro electromagnetic systems, which are tiny electrically signaled mechanical, so not digital, systems, normally for some form of measurement. I mean, it sounds like what I said earlier, right? A little bit. So this insane paper on putting AI on like systems, small chips, to where it learns from the device it's attached to, not made for the device it's attached to, which is really funny. So it's not made for the device, but it's attached to it, so therefore it's learning from it. And it's not for people like you and me. This is why that GitHub we saw earlier, let me find you guys. Hold on, I'm gonna get you out there. I make sure you guys got all the links. And that's why this GitHub right here, this Zap, is a little bit more powerful to see. So taking something made for industries and commercial use, made for commercial for digital flammers, electro signal sonic blasters. In case you're wondering what that actually means, it just means people talking a whole bunch of hot words that don't mean anything. Electro signal sonic blasters. And what up, Bitcoin Live DB? Thank you for joining in. I hope you're enjoying the show. I see you do love the show. Hope you're enjoying today's episode. Because I know right now we're just kind of getting into what are small AIs right now? What are they? And we're proving that basically small AIs are on industry machines, normally designed to find flesh or humans or creatures or bodies, non-mechanical things. And they're using very small instruments to do it. Cool. And we've gone across a couple papers about putting like deep learning and other things on these small tiny little chips within about a 1 megabyte size. So on this IE Explorer, I found this. Wow, it's still loading in. It's huge. It really is a huge paper though, so we get to do something. But basically, this paper came out and it really shows why so many real devs and industry leaders are looking at TensorFlow. Is this loaded? I don't see anything. I'm gonna hit the reload just in case. So this is why everyone's looking at TensorFlow. If we can get the dang thing to show so you guys can see it. So the industry leaders are looking at TensorFlow while the public world is looking at Llama and other deep learning methods. So TensorFlow was made originally for IoT-like devices in the industry fields. We've talked about that, right? And it was made small first, made to be generically specific with little impact, and oftentimes is 100% unsupervised. Now, I've done a completely different episode on AIs where we even talked about the difference between unsupervised and supervised AIs. And unsupervised AIs oftentimes have the hardest challenges and take the longer amounts of time to learn. So the AIs that we're talking about here kind of break away from that, where these are 100% unsupervised that work better than 100% supervised AIs. Like, these work way better than pretty much anything else you see. These are designed where they have to work every single time. Every single time. They have to work. Now, one of the reasons why it's important that these are unsupervised is there's nothing connected to it, right? It's just the device. Now, something a lot of people don't realize, that if the public actually knew that there were 100% unsupervised AIs, they'd probably go insanely nuts, because public AIs are 100% supervised. And some AI companies employ hundreds of employees sometimes. Like, let me rephrase that. AI companies sometimes employ up to hundreds of employees who watch and help the AI give answers, or in some cases, be the actual full program chatbot that it claimed to be. An AI company hired engineers to do the work of a chatbot. Dead serious. And the chatbot company didn't even think that this was a problem to do, because it was already considered common. And let's go up and see how old this is. Get out of reader mode so we can see how old this is. This year. That happened this year. June 6, 2025. Damn. That's some hard hitting shit, right? It's already a common thing to do to hire engineers to just be able to quickly type chat responses to people. They need engineers to be able to handle complicated workflows in their brain that a computer would normally do. Alright. Now, whom would I be? But I didn't at least show you a way to get there. This is the actual TensorFlow Lite Micro Edition, TFL Micro, for putting TensorFlow on microcontrollers. Now, this is one to use for the Flip Zero, but maybe strip it down somehow. Prune it or something, right? That's what we're going to have to do. Most definitely. So, whoever does AI already knows where I'm about to go next, because I'm talking about pruning it. I'm talking about doing the tame. So, I'm pretty sure Keras works with Rust, and Rust can be used in C or with C or whatever, and so many ways can, or like you can use Rust to code C, I think is what I'm trying to say, and in so many ways you can do with this. But if you can prune a Kara, you can prune literally anything. Karas are supposed to be the smallest TensorFlow model in the first place, and there is a way to actually prune it, so that way you can fit TensorFlow models pretty much on devices like flippers. We will definitely need pruned Kara models. Alright, so I'm going to get rid of these older ones and give you back these links. Here's the GitHub, in case you wanted to go find out more about TFL Lite, Micro. Well, I don't know, I keep saying like TFL Micro. And then Karas, and let's go into the next one. Build fast, sparse, on-device models with the new TFMOT pruning API. What the hell does that really mean? Automated pruning. At the moment, you may be really thinking, why would you even want to prune so much? Like, in the Bitcoin world, pruning is considered basically like a sin, similar to forgetting something. That's how a lot of people look at it. But most don't like it, but AI models, pruning is like a godsend. It is how you get AIs to do extremely specific tasks on a generic level. So we're going to read the introduction. Pruning is one of the core optimization techniques provided in the TFL Model Optimization Toolkit. That's what TFMOT means. Not only does it help to significantly reduce model size, but it can also be used to accelerate CPU interface on mobile and web. Oh my gosh! Yeah, they're literally talking about using TensorFlow to completely handle how the interface is put onto the screen. One of the things we need for the Flipper Zero. With modern compute-intensive models, their area of pruning as a model optimization technique has drawn significant attention, demonstrating that dense networks can be easily pruned, a fraction of the weight set to zero, with negligible quality degradation. Today, we are excited to announce a set of updates to TFMOT pruning API that simply pruning and enable developers to build sparse models on for fast on-device interfaces. Gosh, this is actually no joke, and this feature was actually introduced, or the API was introduced in 2019, and now that they're taking that to the next level, you're actually able to do even more with this. Insane what all you can really do, and you can prune to specific situations. So it's gone above and beyond the normal type of thing, and TFL. Okay. Get you that link one more time before we drop it off the screen and we go on to the next spot, because you know you're not going to get everywhere with just one thing. AI is all about, like, full functional AIs that we've been talking about, they're all about like having the options. So TinyML is getting started with TensorFlow Lite with microcontrollers. So remember earlier we were talking about TinyML. Now here is specifically TinyML with microcontrollers. So I know not all the doers like to read, and believe it or not, this thing up here at the top is a video it's refusing to load. That's probably a good thing. It's probably faster right now. But there's actually a YouTube video right here on the top, so if you come check it out yourself, you can view the video. You don't have to read. They also have pictures. They have really good, actually really good quality stuff. Help you train your data, get it set up on the breadboard, do all the testing, install everything, literally step-by-step instructions. I even if you don't understand what it means, they tell you what to click on, they tell you what to do. So they show you it and they say, look, model file, library, like this spot right here, bro. They're holding your hand, like, you know that meme with the grandma, that's you right now, and that's these people are holding your hand, taking you back to bed while you get your TensorFlow set up on a microcontroller. Now, keep in mind, this is actually all four completely different microcontrollers. You see right here, it is a Nucleo 32 STM32L40 432KC, and the one on the Zero is an STM32L4 something. It's slightly different. Equivalable. And when I say equivalable, I do mean that 99% of the code should work exactly the same. The only thing that's going to be different is like how you, so like here you need a breadboard here. Flipper Zero has a built-in breadboard basically, or has a built-in GPIO. So you can, whenever it says you're going to need this to do this for GPIO, you can just go to your GPIO. So you can bypass some of the instructions in here with the Flipper Zero. You won't need all of it, which is nice. So how to actually use it on an ESP32. So the Flipper device uses a very generic controller, but not the ESP32. I'm pretty sure the ESP32 is available on the dev board kit, as well as a bunch of other hats you can purchase for your Flipper. And it's kind of important to notice, because the ESP32 is one of the most common microcontrollers, and it's also used for the Arduino. So we're going to go through a lot of stuff that will be for the Arduino. Now, in many ways, yeah, sure, whatever, but tons of stuff for the Arduino does work on the Flipper with slight modifications, because you're strict C, not C++ allowed, and some other things like that. But, you know, we are really getting to stuff that's actually usable. And what I'm really saying is, the reason why I'm able to find all this information on getting like TFL Lite or TFL on ESP32 with Arduinos, with the SMT32 chipsets, these are the controllers of the industry, the mechanical of the digital world. These are those microcontrollers that run them, and that's the stuff on some of these extremely small cheaper devices. And hence why I'm pretty sure they're going to work for the Flipper with, like, again, modifications, because of stuff like, you know, strict C and all that. He's got a point. Let's keep going. I thought we loaded everything in. Don't worry, a llama has actually been found its way to the Flipper. It's like a household TensorFlow on steroids. Dead serious. A llama really is a household TensorFlow on steroids. It is as if you had Liverman in your house to open everything for you, including your mouth, so you could eat. A bit excessive, sure, but it does get the job done. So TensorFlow is set up to where once you get it running the way you want it, it will just keep doing that. A llama, however, is slightly different, where it doesn't always do the same thing the same way twice, even though it might get the same outcome twice. It doesn't always. It normally gets the same outcome every time, over time, even if it doesn't do it the same way twice every time. So TensorFlow is like metal. It's rigid, it's hard, and it's useful. While a llama is like a superfluid. It's cool, it's neat, it's useful. It's a pain in the ass to use half the time. And to be honest, there really is the phrase, "Have you seen my superfluid? I think it ran away." Superfluid is frictionless or zero velocity fluid flow. It will creep up over containers and empty itself out of them. And if you can stir it in the right way, where it adapts, there is sometimes it won't stop, okay, is what we're saying. You can actually stir it just a little bit, and because it has that zero velocity, it just keeps stirring itself. So it says here, superfluid helium creeps up the wall of the container and drips down. It literally escapes out of its containment units. So think of a llama like, once you stir it, it just keeps spinning. Okay? You know what? You know what? I have to say this. TensorFlow is probably the best bet to getting most out of a small factor device with AI, with the AI also being small factor, like the Flipper Zero. But you are not here just for that, are you? Okay, the superfluid is out of the cup. Let's look into some of the smallest possible AIs that, in some manner combination, together would make potentially a somewhat full, capable, usable, blah, blah, blah AI that will fit within a Bitcoin block. Now, in case you're wondering, I am trying to see if we got more stuff loaded. So it looks like some of the stuff loaded was first in the back of the show, so my apologies for that. Now, let's get back into the thick of it, because guess what? We're talking about AI. Here we go. I just gotta whistle at the OBS for OBS to respond, bro. Alright, so when I was first looking and doing the reflective AI, this kept coming up over and over and over, and at this point, I just at least have to point it out to you. I don't know if it's even out yet, just pointing out the fact that reflective AI with deep memory tricks that we kind of going to be talking about, and we have talked about the deep memory tricks in AI miniseries. Well, these are sometimes the best user interfaces because they change naturally for the user based on the user. Most people only use these for chatbots, which can be useful, but action-based reflective AI can adjust your layout, edit settings, and even run applications in the manner that you would do it. Kind of insane, and it's the reason why people like it. Oh. And just make sure you guys got that link dude on it. We're going to the next one. So here is that Google-based keyword spotting. I hinted at earlier, or at the very beginning, and when we saw the paper on it. So you can do very good work at getting usable responsibles most people in that language will understand. Now, I don't know all languages this is actually for, but we're going to read the first two paragraphs. So you see, Google curl. A key phrase detector, often referred to a keyword spotter, KWS, is a simple speech processing application that detects the presence of a predetermined word or short phrase in stream of audio. This is commonly encountered nowadays with hot words or wake words, such as "Okay Google," "Alexa," that are used in digital assistants to tell them when to start listening. The repo contains a key phrase detection model that can detect up to about 140 short key phrases, such as "move left," "position forward," in a 2-second window of audio, which output neuron of a neural network corresponds to a key phrase, and full list can be found here. So basically what we're saying is it allows you to say short phrases within 2 seconds, and you see a lot of times it's 2 to 3 words is max. That then the model will detect it and send that information to a neural network to then correspond to it. Speech to text, without having to listen first. Okay, we have all these devices in our house, always listening to us all the fucking time, but there does exist a way to only hear the word you want to hear. What? And it's small, simple, but it is, like you see, last comments or the last made edits was 6. Like you see, last comments or the last made edits was 6 years ago. So it has been around, but it hasn't technically. If you don't think about it, it hasn't been around as long as it seems. Wow, voice controlled snake game. Love it, love it. Okay. My button over there. MCU Net V2. Memory efficient patch based interface for tiny deep learning. You probably want tiny deep learning while we're at it, don't you? Allows your AI to adjust and learn things. Let's see. Tiny deep learning on microcontroller units, MCUs, is challenging due to the limited memory size. We find that memory bottlenecks is due to the imbalanced memory distribution in convolutional neural networks, CNNs. The first several blocks have an order of magnitude larger memory usage than the rest of the entire network. To alleviate this issue, we propose a generic patch-by-patch interface scheduling which operates only due to a small spatial region of the feature map and significantly cuts down the spark or the peak memory. However, native implication brings overlap, patches, and computation overhead. We further propose network distribution to shift the respective field and flops to the later stage and reduce the computational overhead. Manually distributing the receptive field is difficult. We automate the process with neural architecture search to jointly optimize and the neural architecture interface scheduling, leading to the MCU Net V2 patch-based interface, effectively reducing the peak memory usage of existing networks by 4 to 8 times. Co-designing with neural networks, MCU Net 2 or MCU Net V2 sets a record image net accuracy of 71.8% and achieves sometimes just under 90% accuracy on the visual wake words dataset under 32 kilobyte SRAM. MicroNet, or the MCU Net V2, uses also unblocks object detection on many devices, achieving a 16.9 higher MPA on Pascal Vox compared to the state-of-art visuals. So they're talking about like Pascal voice on command machines. Our study largely addressed the memory bottleneck in tiny MLs and paved the way for various vision applications beyond image classification. That's really important. Like means tracking and all sorts of other stuff. But even understanding and learning from. Small form factor, 32 kilobyte, that said. That's almost small enough to run on the Flipper Zero. Like, without needing to be a plugin or JavaScript or anything like that. Wow. Whoa, buddy. It's not happy the fact that I had yeah, it's not happy that I have or supposed to have a VPN running. It's not letting the VPN run, and it's blocking me. Give me a second. We're gonna do a little trick here. Oh wow, chatbots. Thank you. That means something. It means a lot of good things, and a lot of bad things. Don't worry, we're working on it. We're working on it. Basically, it's an actual like dead on, dead serious, like really strict website. And I'm unable to view it. I may be unable to get you I'm unable to view it right now. For whatever reason. So let's see if we can get a QR made real fast for you. 1 second. I got another screen. Because I always have 2 of these. Alright, hold on. I got to pull up on the other screen. We're gonna bring that up. Let's see. Alright. So, I'm unable to get you a QR. It is paperswithcode.com /dataset visual wake words. When we go back to the other screen, I'll actually get you QR. I say that, but no, I want me to get you a QR. It won't pull up. Never mind. I want me to get you QR for that. So you'll have to search for it. But this is like an official, like, a lot of papers here. These are like this is like actively being worked on right now. And they don't want people just coming here and fucking it up. And my computer literally just got blocked because it said I have requested to try to view the website too many times. So like they're even being restrictive down to the point of viewing their up, and my computer literally just got blocked because it said I have requested to try to view the website too many times. So like they're even being restrictive down to the point of viewing their own website to obtain these visual wake words. That's how important this stuff really is right now in the internet. It is insanely important. Now, I am right now trying to get what you guys are looking at right now put up on the screen, because it looks like this is going to be the main access point for it. And now keep in mind the actual link to the thing that's not letting us view, which I think just popped up on my thing now. Just popped up. I just got loud access again. Woo! Man, boy. Woo! What the heck? Like, sometimes this is the thing we've had before where I was trying to view a paper one time on while we were live, and I had already downloaded the paper, so it was like, oh no, you're not allowed to do this twice. And I got, woo! What the heck? Like, sometimes this is the thing we've had before where I was trying to view a paper one time on while we were live, and I had already downloaded the paper, so it was like, oh no, you're not allowed to do this twice. And I got, I actually got banned from that site, so I can't even go there to get papers anymore. But this is for real, for real. This is legit shit. This is no joke. We're talking about the actual stuff going on. So now that we got you that, let me drop that down. That's taking out a lot of memory. Alright, so this right here is the MCU Mnet. This is their actual GitHub or whatever. This is made specifically for devices with memory under 256 kilobyte. So basically that means that the max memory on it is 256, but it doesn't take up the full amount of memory. Because it's got to have something else running, like it's the screen, drivers, other things. And so the visual wake words we saw a second ago, that's like a smaller variant. The one that the website first blocked me, they're actually the world's smallest variant of this one right here. This one's small. This one is 256 kilobytes. Okay? Right here says it, 256 kilobytes. Wait, the other one we were looking at, the visual wake words data set, is even smaller. That's how important that is. And the visual wake words is being able to use not just audio, visuals. Being able to put write on a piece of paper and put it in front of there. It says help me, and it'd be able to respond, or oi bro, and it'd be able to respond. And this is stuff that's basically not actually recording or watching or doing anything. And then it has a way to, when you interrupt whatever it's doing, which is nothing really, it's just like checking basically if something's moving, so to speak. The second you interrupt that, it then turns on. And that's the beauty of this. This allows battery saving, data saving. So it's not always on connection stuff. And so this makes it like a really perfect fit for what we're looking for. Now, one of the things I have to point out, MCUNet is specifically designed around human detection, detecting people. And you see right here in the middle, it says visual wake words, right? The human walking in front of the screen is the visual wake word. So you understand that now. Let me get you that link. Alright, we're going to go on to the next thing. Okay, 3D print that. Looks like he did. Or maybe, I don't know, he might have whittled that down himself out of like PVC piping. But look, it's like a diode and a light on a wire. And you could do that slightly differently to work with the flipper. Alright, so come on. Oh, come on. There we go. So, this is another flash detection system. But these algos were first made, again, for the industry's equipment system to save lives. Then geeks, nerds, dorks are learning how to reason this old tech in new ways. And I guess you could say that's just kind of what we do. Well, it's not loading, but that's all this site is about. We're not going to go over it. That's for me to give to you in case you're wanting to do this. Because you're going to need this. Kind of important. But here's the official GitHub. In case you like this idea of the flipper handling your lights or something neat in your house. Imagine you got your flipper hung on the wall, like, you know, and it has a camera attached to its GPIO and stuff, and or through the Wi-Fi. Well, not Wi-Fi, but through the direct cable connection using Droid, you know, like a Droid cam or something like that. Basically, it's basically your host and handling intruders. It has text to speech, so I can talk to people. You can see them when they come in. Yeah, it's a little dumb, but it's something cool to be able to do. You know, and you can do it with just an Android and an Android phone and a flipper. And you can basically have a full service AI-based security feed that's also, thanks to the Droid Cam, it's all done with Android phones as webcams over the USB line. So nothing over the air. So it's still kind of sort of private-ish. Fully offline. You're going to need all this to get you there, because this is the actual TFL light. This is specifically for micro. This is for what we're talking about. These are for microcontrollers. So this is on the Arduino Uno. This takes tiny machine learning to a new state with light return responses. If Flipper Zero has controllable LED light, and other devices have the ability to read that as a signal, including humans, like Morse code. This allows you to turn any LED into a response system for a computer to a human, and for computer to a computer. Cool. So if you want one on your, see how that's on the breadboard like that, the little diode, and you can actually set one of these up on your Flipper Zero. I think it's left to have a diode. But you can have set up on where the Flipper Zero would be able to turn it on and off. But there's actually a LED on the Flipper Zero, so you could just have the any AI you have to be able to turn on and off a light to give you responses that are like yes or no, maybe, or something, or whenever the screen is occupied, instead of just using the screen. It allows you the opportunity to multitask when multitask really isn't. I mean, it allows you to multi-output. How about that? Not multitask, multi-output. Alright, so one of the key things that we're going to be looking at, because obviously Keras is making a comeback, is anomaly detection. So this is used to take a picture or a common state that doesn't really change, and have an AI model that basically detects changes, like seeing a negative void on the image. This is basically an uber fast, uber slim way to detect something. Then you hand it off that output, like where it's at and stuff, to be utilized in object recognition or human recognizing. Does all the actual work. So this is like a plugin that handles a combined process that uses most of the AI over JavaScript handling for higher command control without as many Fury issues. And yes, I am talking about specifically Flipper Zero there, but basically this allows you to detect anomalies in things automatically. So it's a variant of the autoencoder, and it's super fucking small, because that is the theme of today. And we're just going smaller and smaller, in case you haven't noticed. Now, if you're talking about hardware-based tasks, proxyless NAS, it's your bra. This is going to be the sauce and the source to collectively pull all the hardware on the device together for the AI, of course. Because you can customize proxyless NAS as a feature. Yeah. Nice. It's actually nice. It's actually really fucking good. Look at that. Damn. Efficient motherfuckers. Love efficiency. So this is actually like one of the things here, and it's definitely gonna get you where you need to go, blah blah blah, all that fun stuff. So here is the PyTorch for proxyless NAND. And this is basically the full-on guide to you getting it going. Okay. Full-on guide. So, a few moments ago, I said you would probably need object recognition. When we're talking about handing that thing off, you need object recognition. There's an entire zoo for this. So, this is that type of machine learning right here, and it's a zoo of it. Machine learning zoo one, bro. Go pet the machine learning. Now, this is probably the best resource to get micro deep learning on small form factor devices. And I am going to have to use a translating tool because it's in Chinese. So that's why it's not in reader mode, because reader mode you can't translate in there. It looks like we're having some problems translating today. Yeah, this is the best resource for this. It really is. Because like these people get it down even smaller, and we're having problems. I'm just gonna drop the page. Let me make sure I get you the link. Yeah, you can actually translate this. You can view it. It is allowed. It's pop-up popping up. It's an ad. How it works over there. We're going to switch over while that does its thing. So, but that's the resource to get deep learning on small form factor devices. Oh, pop down. Yeah, there it goes. Finally. This is the way to do it. And they got lots of resources here. Tons and tons. I just wish you could see it. Well, I mean, you can. You just got to translate on your end. Alright, so we're going back to the GitHub. Okay. Remember that tiny little chatbot we saw earlier where they were like, add attention? Because that Google made, in case you're wondering, adding attention to AI was that Google made thing that made AI actually really good at stuff. So this keeps everything under about 20 kilobytes with active various RAM usage. That's the SRAM plus flash. And damn, that is small. The header is probably the heap of it. Yes, that was a joke. 94% accuracy. Woo! We can get it up to about 2.6. I believe that's megabytes. Alright. Alright. So I literally just showed you a collection of AIs that should 100% code plus prune models plus the deep memory with some object recognition, with some kind of state change recognition, allowing some form of gesture or audio gesture, having some amount of reflective response, and a way to do chat 3 ways. So you have like a chat that is a small data set. You have the chat that just does basic output to the user or the light, and then the smallest possible speech with attention, plus a slew of other things that should fit within a 1 megabyte. So if you go back and grab all the AI from the last time I did to this, like the last time I was in one of these little backroom talks right now, you should be able to fit them all within about 3 megabytes in total. It means all of them to go together was 3 megabytes. Working, running, processing, everything, plus saved with the code save. It's 100%. All of it running at the same time, fully on the same thing, 3 megabytes. But if you actually went back and just picked the smallest ones we showed you to do the few things I'm talking about, it's only about 600 kilobytes. There's actually 3 AIs we went over that do the exact same thing. You only need one of, there's 3 options. And the 600 kilobyte does include the 3 forms of speech. That's the actual, like, being able to understand voice, being able to use voice as controls, being able to use the physical gesture like voice, being able to use basic anomaly detection with basic machine learning, tiny ML, and deep learning, basic person detection systems, all under 600 megabytes, or within 600 megabytes. That includes the operational peak RAM, plus total size with the flash memory and code base. 600 megabytes. So if you still have room to actually put Bitcoin transactions in that block as well, you could store a multifunctional AI for Bitcoiners by storing it completely on-chain, including the possibility to have it downloaded, compiled, and ran within the block that it's on, to allow some hardware wallet to access it, or even like Flipper Zillow with a dev hat, and actually be able to then do Bitcoin stuff through the Bitcoin AI that's actually saved, compiled, and loaded in a technical block. Now keep in mind, when I say all that, you can put the files in a block. You can put the compiled bash files in the block. And you can put like a resource type save file dump in the block. Now, 600 megabytes. Then when your device loads those in the order reverse, like in the same order I said it. So code base, then the I don't have it written down. Anyways, in the same order I just said, the 3, the code base, and then I forgot my words. Anyways, you get all 600 megabytes. So you can have the code base, you can have the precompiled bash files, and then you can have the basically like a screenshot save spot to know where to load from. On all 600 megabytes, so you can load it up and your device can just go talk and be like, yeah, I need to know my thing go through, or, you know, like technically trustless AI utilization of the blockchain because it's in the blockchain. Now, there's still going to be more you'll have to do. It's not exactly as clean cut as I say it, but it is technically possible. Now, we need to find the smallest AIs I could find, and we're going to bring them up to you. So this next bit is literally just the small AIs. It's not a presentation, it's more like information of where you can find them. This is the world's smallest AI that I could actually get my hands on. And for some reason, finding more information on what's called simple perception, basic linear classifiers, in C specifically, they're actually really hard to find. These are the world's smallest AIs possible, with some being completely usable within 2 kilobytes. And when I say that, that is the code base, the flash, and the RAM within 2 kilobytes. That is insanely small. And it does tasks. It does work. It's legit. And this guy is basically the best the best spot that actually shows you to get one that actually does do this actual work. Super small. I mean, like you see, almost the entire code is on the screen already. Super small. So perception algorithm classification using sklearn. This is potentially the best way to get that BLC, the basic linear classifications of simple perception, basic. So BLC SPs under 2 kilobytes. This is basically the way to do it. Yep. So now keep in mind, we started at the world's smallest and we went slightly bigger. This one is now slightly bigger. So this isn't the world's smallest, but I wanted, like, this is a real neural network. And it's a single neural network. Right? Is this a single? Hold on a second. Yeah. So for about 1 kilobyte more than the other one, for about 3 kilobytes total, you can actually have a technical full neural network. Now, it's a bit more tricky because this does expand. And, oh no, my bad. This one actually starts as a 2 base neural network. The very smallest one was a 1 base neural network. This is a 2 connection or 2 base neural network. Again, this one's using TensorFlow. While the other one was simply directly coded in C, this one's using TensorFlow. Now, if 2 bits is not enough, I can understand. Some people, 2 bits is not enough. So here's the world's smallest 4-bit neural network. This will get you to, like, doing XOR gates, XOR gates, and some other higher computationals than just recognition of stuff or classifications of stuff, like the world's smallest neural network AIs actually are. So we're going from being able to do classifications, and the second one was predictable patterns, like one we just did, and now we're finally doing one where we're actually starting to get real computational work. And from my understanding, this one specifically was like someone's paper or whatever, and it's only really being used for like demos and stuff. But from my understanding, it's fully functional and actually works. But it's Jupyter's Notebook, so good luck there, boy. So there are more like what I build. Oh my god, these are more like what I build. So when I build AIs and this kind of stuff, I'm normally do decision trees or tree classifications, and there are on record some of these tiny DTSs being as small as 25 kilobytes in working practice. Again, codebase, SRAM, plus flash, 25 kilobytes, working practice, that is actually small enough to put on the Flipper Zero to run in line with an application without being a plugin or JavaScript. Like dead ass, all on, part of the code, it can do this. Insane. This is actually one that I've been looking through, learning from. I didn't know they could get so small. Alright. Here is a small decision tree training program. Now, this is not an AI. This is to train the small training trees. The small decision trees we just looked at. This is to train these. Okay. And I say this is not AI, but going through here, it looks like it might actually be like it might actually whatever, or the person who initially did this had it going like that. But when I was like looking at forums and stuff where people were talking about it, I saw tons of people talking about how like basically it wasn't what they were expecting. They were expecting more like what this is offering, is what people were expecting. This is fully ready to go out of the box, that thing. While this was more like just a training thing that you have to include into something else. But this is also C++, while this is not C++. Huge differences. Alright, so a lot of what is going on is, well, basically some of the AIs I presented that can fit within a Bitcoin block on their own are some of the world's smallest AIs period. Okay? And then I showed you the actual world's smallest AIs. So how small do they go? A suit of AIs can fit inside a Bitcoin block. Hold on. I just think that's important. A suit of AIs can actually fit inside a Bitcoin block. And yes, many of them will even fit on Flipper Zero. Maybe with a dev hat for a couple of them, but hey, that's more than what some people have already. Before today, you probably had this illusion that AI is always uber complicated and always needs the bigger machines, like kind of like the more cowbell, but with GPUs. In reality, some of the most innovative and brand spanking new AIs, because some of the ones I demonstrated are less than a year old, well, they are the smallest functional AIs that actually exist. Because when your AI isn't about entertaining the person using it, sorry, that's what most AIs actually do, but it's actually about getting work done. Well, man, does AI get the low down dirty bit done work. Oh, my bad, I said that backwards. Boy, does the AI get the low down bit dirty work done. So what's stopping someone from having a Bitcoin AI that's the world's directly installed Bitcoin clock or something? Well, it's time, energy, and money, basically. Most probably. Because the AI already exists. They just got to use it. Functional AI is what made Google look for attention systems, which then I don't know if it was really caused or discovered by them or whatever, but then what made attention AI, which is now the most common forms of AI out there. And I mean, I don't think there's a whole lot of other ways to say it.
Yo, did you think you know? Did you think you hold? Did you think something new? That's the goal, to see from a new degree and get the change your mind needs to find something new. Life suddenly is easy for many, but when a wall appears, sometimes up is all you see. So let 3D guide to the side, yo, where there's a door though. Just be careful on your way out, for the first step is a do-si-do. A little bit Linus with something different, it's almost like he's something else. And regardless of maybe, perhaps it was that missing piece you was needing. Maybe it was that simple message you was searching. Definitely it's just in different time for defraying a mental mind state, separating us from our own mental mind tank. Boom goes the blast of thought. Boom goes the last spark with part. Boom goes the mental mind tank. Don't your perspective hit on the way out. Don't let your directive stop you when you doubt. Don't let the dire detection stop you from being getting excited. So the photons are delighted. Don't hesitate so we can line up the hash rate. Let me surmise the time, submit the rate, and reduce the face while we mine our major banks. Crypto technology like cryptographic money, while hashing your life into a set of QRs. It doesn't matter, cause this was 3D changes perspectives.
Thank you for joining the show.
Please return next time for a new role of perspective. Thank you for joining the show.
Please return next time for a brand new perspective. Of perspective.
Thank you for joining the show.
Please return next time for a brand new perspective.
Thank you for joining